Let's take a look at number 10. This is again a problem that says that we are proportional to the amount that is left. So we know our equation is going to be set up, dy being the amount of oil left equals, or dy dt equals k times y, or y equals c times e to the kt. Then it says write an equation for y, the amount of oil that's left given these conditions. So as we've done before, we just substitute this initial value in, and our equation will be y equals 1 million e to the kt. Substitute in the given amount of 500,000 when our t was 6, or 6 times k. Divide by a million. 500,000 divided by a million gives us 1/2. That's going to equal e to the 6k. Natural log of 1/2 would equal 6k, or k equals the natural log of 1/2 divided by 6. Okay. Substituting that into our equation will be P equals 1 million e to the natural log of 1/2 divided by 6 times t. Okay. Next it said, at what rate is the amount of oil in the well decreasing when there is 6,000 or 600,000 gallons of oil remaining? That particular problem is going to go back to our dy dt equals k times y. Again, it says at what rate is the amount decreasing. Well, we know what k is, so dy dt is equal to the natural log of 1/2 divided by 6 times y. So this one just simply becomes a matter of substitution. Dy dt equals the natural log of 1/2 divided by 6 times that amount that's left, 600,000, which is going to be equal to, just divide by 6, 100,000 times the natural log of 1/2. And that will be, units here will be gallons per year. Let's go ahead and take a look at our next problem. And if I am correct, we should have a free response problem. Okay? So this free response problem comes from the 2015 AP exam. And it gives us a differential equation, and then it says go ahead and do a slope field. This is going to be a non-calculator problem. This is number 4. It means no calculator. I can't use my function. But as I look at this, one observation I can do is I say, wait a second, there's not a lot of points here, but I see all of these are when x equals 0. When x equals 0, this simply becomes dy dx equals the opposite of y. So at 1, I should put a tick mark that has a slope of -1. It's kind of pointing from here to here. At -1, I should have a +1. It should kind of point up in that direction. At 2, I should be -2. It should be pointing down like this. Now let's fill out these. Well, why not just do like we did on the last one, and let's say x equals 1. When x equals 1, dy dx will simply be 2 times 1, or 2, minus y. 2 minus 2 gives us a slope of 0. 2 minus 1 will give us a slope of 1. No dots here, 1 dot here, 2 minus a negative a negative 1 is going to give us a slope of 3. So this one should be kind of going up in this direction. Should be steeper than that last one. Okay, so this is worth 2 points on this problem just by doing that slope field. Let's take a look at our next one, and this says dy squared dx squared in terms of dy dx is what we need to find first. All right? So before I read the rest of that, let me make sure I find this first. And it does say leave in terms of y and x. So we're given this. So to find that second derivative, I'm going to take a derivative of this, which is just going to be a 2, since that's with respect to x. But when I take the derivative of y, that's a dy dx. This is not in terms of x and y. What I need to do is go ahead and substitute in that value of dy dx. So our second derivative will equal 2 minus the quantity of 2x minus y. And there we have it. Okay? Now the next part of this question says determine the concavity of all solutions in the second quadrant. What do we remember about the second quadrant? We know in quadrant number 2 that our x is less than 0 and our y is greater than 0. So let's consider this second derivative in there because that's going to determine our concavity. If I look at this, I'm going to go ahead and distribute this negative just so that I can clearly see that the second derivative is going to be a 2 minus 2x plus y. Now wait a second here. If this is always going to be a negative number, won't I get a positive here? And y is already going to be positive, and we're adding that to 2, which is positive. Therefore, dy squared dx squared is always going to be greater than 0 in quadrant number 2. Therefore, we must be concave up the whole time we're in quadrant number 2. That was worth 2 points, one for finding our second derivative right here, and then for answering that question. Next, it asks us to let f of x be the particular solution to this differential equation with an initial condition. And does this result in a relative min or max? So again, it's checking our understanding of these terms, relative min, relative max. Well, I know that mins and maxes always occur where our first derivative equals 0 and our second derivative is either greater than 0 or less than 0, concave up, concave down. I just found the second derivative. They gave me the first derivative, so let's use that to determine this. So it's at this particular point here when x equals 2 and y equals 3. Let's find, first of all, dy dx at those. Substituting in, this will be a 2 times 2 minus 3. That's 4. 4 minus 3 is 1. So wait a second. This is not equal to 0. Can we have a max or min if our slope is not 0? No, we can't. So this one is definitely a neither. Let's take a look at the final part of this to get our final 3 points. This says, let's use this to find the solution to our differential equation. The good old y equals mx plus b. So if y equals mx plus b, that means our slope is going to be m, which of course is equal to dy dx. So I'm going to just say that the slope m is equal to 2x minus y. Once we have that down, I'm going to substitute in what they said our solution is. They said let's make y equal mx plus b. I'm going to substitute that in. M equals 2x minus that quantity. I'm going to subtract the m from both sides. And I'm going to group these two guys together and factor out the x. This will be a 2 minus m times x distribute this, I distributed that to get the m negative there, and this would be a negative b. Or in other words, 2 minus m times x minus b plus m. When I look at this, I can say, well, let's set this equal to 0 here. 2 minus m equals 0, which would mean that m would have to equal 2. Okay? When this is 0, that would mean that b has to equal the opposite of m. If m is 2, then b would have to be negative 2. That is the conclusion to that problem.